You're at a restaurant and the check comes to a total of 15 bucks. You want to leave a 17.5% tip. How much money should you pay to the nearest cent? So we know that the total here is $15. You're going to pay 17.5% on that. So we'll start with the $15. Then we'll apply the percent of change on this one. So, as usual, we got 1, because that always represents 100% of what you're paying. That's the $15 right there as a percent. But then it says that you're going to leave a 17.5% tip, and we can find the decimal value for that by moving the decimal 2 times to the left. So 17.5% ends up being 0.175. So for the percent of change, we're going to add that value to the 100%, and that was 0.175. Now this kind of looks like one of those growth or decay problems, but it's just a tip, so we don't actually have to raise this to any power. It's just one individual percent of change. And so this is something I can just put directly into the calculator. I don't really need to combine the 1 plus the 0.175 like you would with order of operations. So when I put this in the calculator, it gave me 17.625. We're rounding this to the nearest penny, so the 2, I'll have to add 1 to that too because of the 5 to its right. So it looks like this total that you would pay would be the $17.63. The objective, I can find an average rate of change for a specific interval. This is probably a new word for us, interval, but we'll talk about it. Take 30 seconds, copy this down, then we'll talk about it. Just as a quick reminder, rate of change is another name for slope. And so when it's saying we want an average rate of change, I really don't care that it says average. We're looking for the slope formula on these, which we've seen. Remember the slope formula, it's written as a fraction like this, and then it's always subtraction between the values. And in addition to that, it's always x values on the bottom, because that's the run, not the runs, just the run. And then the top number is the y value, that's the rise, because y's are up and down. So we'll need to remember that when we look at ordered pairs. The other thing we see on this is the word interval. Well, we'll go over that, okay, because this is, again, it's a very new word for us. So here we go. We got interval notation, and it says it's going to use these brackets like this. Now, you can see it says it's this and this. You got the square brackets and another square bracket. Open and then close the square brackets. So what you'll see is you're going to have the square brackets, but it's going to have values that go along with it. So you may have a value first, and then you may have a second value, and these are separated by a comma. If you see that these are square brackets, this is not an ordered pair. It's not like we've changed the way an ordered pair looks. It's not x and y. These are both x values, which we're going to need to understand because we're going to see this a lot. Now, for me, that's about all I really want to cover with interval notation. You may see it like, again, you're going to see it like this. You will see these as numbers, not x1 and x2. Okay, so in other words, you may see an interval that looks something like this, maybe -5 all the way to 3, something like this. But those two, the -5 and the 3, those are both x values. They are not, this is not an ordered pair. These are x values, which then we can find the corresponding y value that goes with these x values. So you'll see on some of the graphs at least, maybe you'll even notice in the tables, that some of them are linear, some of them are exponential. We don't give a crap about that, okay? I don't care if they are linear, I don't care if they're exponential. All I care about is these two x values in the interval. You'll see on some graphs that the scale is kind of different, so we may have to actually end up approximating some of the corresponding y values, but we can definitely use the x values that are given to us. So after that, then we use the slope formula, right? Remember we saw that? Remember the x values on the bottom, y is on the top. So if you had the ordered pair, let's say you had the ordered pair -5, 8. Okay, so the x is -5, so you put that on the bottom, and then the y value is 8, you put that on the top. Okay, and it would work that way with another ordered pair. You need another ordered pair to put in here. But again, on some of these graphs, you're going to see that it's not going to go through a grid corner, so we're going to have to estimate those values. If the values are given in a table, then we don't actually have to end up doing any approximating. So keep in mind, if you do need to approximate any of the values, the assignment allows for a range of values to work. So if you don't get the exact value, you don't have to worry about that. The assignment should still give you full credit as long as you're close, right? Like if the answer is 100 and you put 5 million, okay, that's pretty far off, and the assignment's going to wonder what the crap is going on. Just you're too far off. So you can't be too far off, but you do have a range of values that work. This slope formula stuff right here, which is, it's calling it rate of change now, but it's the same thing as slope. We covered this pretty extensively in Unit 2, and then we saw it from time to time as well in Unit 1 as well, Unit 3 rather. So I'm saying that because hopefully that's not new to us. The slope formula definitely should not be new to us. Find the rate of change from -1 to 0. Again, this is not an ordered pair. I'm just going to stress that every time on this, okay? But it is a rate of change, and rate of change represents, it's just another way to say slope, okay? So the slope formula is always a fraction, so that's division, and then we got subtraction between the values. In addition to that, it's always x values on the bottom, y values on the top for the ordered pairs. So first up, I see that we have an x value, that's -1. So for this assignment, you're going to want to pay attention to the scales of the axes. Okay, so my y-axis, I can see each line goes up by 1. I can see all my x-axis lines go up by 1 as well. So my first x value is -1. So this means that on my x number line, I find -1. Boom, I found it right there. Okay, so I found -1 here. So I'm going to follow that line up. See if I can do this decent. It's kind of a jacked up line, but I can see that it goes up to this point right here, which is giving me the ordered pair -1, 12. So I have an x value, which I already knew was going to be -1 from the interval, so that would go on the bottom. But its corresponding y value is 12. That has to go on the top. So there's one. The next value that it gives me is an x value that's 0 right there. So that's my second x value. Again, that's not an ordered pair, that's an interval. So I find where x is 0 on the x number line. Boom, I found it right there. It's showing 0. And so I'm going to follow that line up until I get to the graph, which is right there. So this is my point. That's at 0, 4. So again, I have an x value that's 0, which was in the interval, and then a y value that's 4. X's go on the bottom of my formula, so the 0's on the bottom because it's an x value. The y value is 4. Y's go on the top, 4 on the top. So we have these ordered pairs, -1, 12. We have 0, 4. And that's, well, that's an ordered pair, those two sets of ordered pairs. So I'm ready to put this into the calculator. Now, again, when I put this into the calculator, I need my numerator in parentheses. So you're going to open up a set of parentheses. That's the button directly above 8. Then you're going to type in 12 minus 4. And then you're going to close that set of parentheses. That's telling the calculator, I just want you to do this. This is my numerator. The fraction line, though, is the divide button. Now, on the calculator, it's going to show a slash, and that's okay, because that's another way to show division. But then the denominator also needs to be in a set of parentheses. So I got parentheses, then I'll type in -1 minus 0, and then I close it with the set of parentheses again, and then I push enter. Put this into the calculator. It tells me my rate of change is -8. Now on those other problems, we'll see that this is going to be labeled, but for a problem like this where there's no label for my y-axis or my x-axis, that's it right there. So the rate of change for this one is -8. And you can see this on the graph, right? It goes down 8 to the right 1. And even though this is curved because it's exponential, I don't care, right? Because I'm only concerned about these 2 points, these 2 x values specifically. So we will find the approximate rate of change from 100 to 1,000. But again, these are x values for us. So I'm going to use the slope formula as usual. And as usual as well, it's always subtraction in our slope formula. So we start out with this x value, call it x1. Our first x value is 100. Again, this is not an ordered pair. So this is an interval saying we want to know the approximate rate of change for x is 100 all the way to 1,000. So I can see on my x number line that I've got 100 right here. So I do need the corresponding y value for this one so that I can put this into the table. Now, yeah, you could say, well, we know in the slope formula that you got x's on the bottom, y on the top, and we do have an x value already of 100. So you could put that in right now if you wanted to. It just it has to go on the bottom, okay? But what's its corresponding y value? So I see that I've got this point right here in green. And yeah, the x value is 100 right there. What I don't know is the corresponding y value. So I would look at the graph and I'd say, well, right in between, you got to be careful on the scale, by the way, because you notice that we found 100. That was the first line. It's not 1. Like the last problem, each line represents 1 for both the x's and the y's. But now the x values and the y values are representing different scales. So we do have 100 for the x, but you can see every line now for the y is representing 0.2. So right in between there, like I have marked, that would be 0.1. Now it is an approximation. That's okay. I can see that my green point is just a little bit above that. I wouldn't say that it's necessarily halfway between 0.1 and 0.2, but it's pretty close. Now you may come up with a different value than I get. Okay, but I'm going to call that 0.1. I'll call it 0.7, 0.17. All right, and that's going to be my ordered pair. Did you get 0.175? You could have, and that should probably work, okay? But now I can put this into my slope formula as the y value. It always goes on the top, so I now have 0.17. And again, if you add 0.175, you should still be okay. But I need some other ordered pair, and that's where it gives me the ordered pair, or the x value of 1,000 here from the interval. So that's my second x value right there, 1,000. So on the x number line here, I've got to find 1,000. There it is, right there. So that means I'm also going to follow this line up until I reach the actual line of the graph. There it is. Now that is not directly on that line for 1.4. So this point right here, we know the x value is 1,000, and that's okay. But again, I have to estimate my y value. So you may have gotten something that's a little bit different than what I get. And that's okay. Our answers should be fairly close, though. So, I don't know. I'll make it 1.4. I'll say 3, I guess. That seems okay. Maybe even 1.44. Again, that's an estimation. So if you're wondering why did I put 1.43? So right between 1.4 and 1.6 would be 1.5. And it's on the lower half, I would say, of that, between 1.4 and 1.5. So I just made it 1.43. Okay? And again, if you got something different, you should be okay. So for my x value, I know that's 1,000. And then the corresponding y value, 1.43. So I'm going to put this into the calculator. And again, when I do that, I'm going to use parentheses for my numerator and the denominator. The fraction line is just the divide button. So when I put this in, sorry, I don't know what's causing that. When I put this in to my calculator, I will have the rate of change, the approximate rate of change. So let's put this in 0.17 minus 1.43, close parentheses, divided by parentheses 100 minus 1,000, close parentheses. And mine shows a 0.0014. So that's good enough right there. Again, did you get something different? You could have. Maybe your decimal repeats or Maybe yours terminates at a different place value. I don't know. But that's enough to call this our answer. Now, there's something else about this too, is that we do have labels for our x-axis and the y-axis. So we actually probably should label this. So I'm going to put it down here, 0.0014. Now it's always y's per x. So the y-axis is labeled for us right here. It's amount of paint in gallons. So I'm going to put in there, it's 0.0014 gallons. And we'll say per. In fact, on the assignment, what they'll do is they'll say, you got to type this in. So you put gallons, and then one of them is, it's a fraction like this, gallons per, and then we use the X label, which is showing in feet. So it's gallons per, in this case, I guess, foot. We don't know how this paint is being used. I guess it's on the trim, but again, we don't really need that context for the labels, as long as we can see the labels for the Y's and the X's. Y's over X's as a fraction. If you wanted to, you could write this also as 0.0014, and then you'd say gallons per foot. So the reason I'm showing that is because it's going to show up both ways on the assignment. Again, these are exactly the same thing, they're just shown in different ways. So we have this interval from 2 to 15. Again, these are x values. So you could even start by saying I'm gonna start with my x-axis, just find 2 and 15. I'll do it one at a time though, just because I don't know the way I do it. So my first x value is 2. So on my x-axis, I can scan for 2. I found it, it's right there. So I'll say here's 2 for my x value. So I'm going to follow this line up to where the graph is, right? So I'm going to follow this up. Boom, I found it. Now, again, this one is not an exact value. Okay, this ordered pair. I know the x value is 2, and that's fine, but I don't know what that y value is. I'm going to have to estimate that. What I do see is that it's higher than 8,500, but lower than 9,000. So if you're using something like 9,000 or even as low as 8,500, probably not going to work. It needs to be in between. In fact, it's higher than halfway between this, which would be 8,500, 750. I'm going to go a little bit above that. I'm going to say this is 8,800. Now, could you have used a different value? Yes. Maybe you chose 8,700. Maybe you even chose 8,785. I don't know. I don't know what you chose, but I'm going to choose 8,800. Now, again, there is some leeway here for correct answers. You do not have to get exactly what I get, but you should be fairly close. Okay, like if you end up being maybe 2,000 off, that's a little bit much. Okay, but if you're close, within maybe 10 or 15, that's good. So this is my ordered pair, and now that I have that, let's put together our slope formula. Okay, so fraction line with 2, it's always subtraction between, and my x value is 2, so it goes on the bottom. X value is always on the bottom. My corresponding y value, 8,800, y values always go on top. So that's an ordered pair, the first one that I have. The next one that they asked me to use is where the x value is 15. So that's my second x value, and if you wanted to, you could put that into the formula, but I'm going to wait to do that. So this is an x value that's 15, so I find 15 on this number line. Boom, I found it right there. So 15 is right here. I need its corresponding y value, so I'm gonna follow this line up until I hit the graph. So about right there. Now this point, let's zoom in. This point I can see it's higher than this 5,500, just a little bit though. Of course, it's not 6,000 either. That's too high. So when I estimate this, I'm going to make that 5,600. Now again, do you have to use that exact value like I'm going to? No. You may use something that's close to it, but again, you should be close. So I do have the ordered pair of 15, and then I'm going to use 5,600. Okay, so let's go back. And now I have an x value that I could have put in already, but the X value is 15, and the corresponding Y value that we're using here is 5,600. So we'll put this in the calculator. Remember, when you do, just make sure you put the numerator and denominator in parentheses. So there we go. So let's get this in. So this is what I get. And again, yours may be a little different. It may be a little different. Hopefully not a lot different, but a little. I get negative 246. I got 0.1538462, so I'm just going to make it 0.15. Did it tell us to round to the nearest hundredth? It didn't, but we're approximating anyway, so you can choose where you round to. I wouldn't round to the hundreds because it's kind of high. So this is the numerical part of our answer. Now we need to actually label it, right? So my labels, it's always Y's per X. So my Y here is population. Now I wouldn't label it as population. What is population? It's people. There we go. Now, the label's not done, but just keep in mind, how do you get negative 246.15 people? It's math. We don't care that we got a partial value here or that it's negative. Again, we don't know the context of this. I assume that maybe people are just leaving some city. Who knows? But all we care about, and this is negative, by the way, because it's going down. But I don't care that it's negative. It just means that we're losing people somehow. That's people per, and then the X-axis label is in years. Now that it's a unit rate, so it's people per 1 year. So I'm just going to put year on this. So whatever this is, again, I assume it's some kind of city. People are moving out. So they're moving out at about 246 people every year from the city. And that would be that's our answer for this one. It's okay that it's negative. It just indicates that there's people leaving the city or whatever. Now, again, it may show this as some kind of fraction. The per is the fraction line if you need to type that in. But if it's just a drop-down menu, you just choose the one that works best. Find the rate of change from 1 to 5. So again, I don't really care what happens between these two X values, but these are X values. This is not an ordered pair. So they've given us a first X value, which is 1. And they've given us a second X value, which is 5. Now in the table, these are the only values that I need to deal with, meaning if there's any other values, you can pretty much get rid of them. So right here, in the table, your left column is always your X's, and your right column is always the Y's. Now we do need to pay attention to the labels because we're going to have to label our answer as a rate of change, which means it requires both labels in the answer. So first off, we see X is 1, boom, I found it right there. Okay, so that's week 1. Week 1 produces 500 mosquitoes. I don't know the context for this. Maybe they're breeding mosquitoes somehow, or maybe they're just observing. I don't know. It doesn't matter. All I can see here is that week 1 says there's 500 mosquitoes. The second X value is 5, and again, I can see that right here. That would be an X value that's 5, and then its corresponding Y value is showing as 312,500 mosquitoes. And again, we don't know the context. We don't really care. We don't really care what the labels are. Instead of mosquitoes, it could be unicorns. I don't care. But when we get to the labels, we'll deal with it. So this means that 3 and 12,500, I don't care about that. What about 462,500? Don't care. Same with this 6 and then 1,562,500. I don't care about those values because the rate of change is just dealing with X is 1 and then the X is 5. So with my slope formula, I'll start with my first X value, that's 1. And yeah, X is always going on the bottom, Y is always going on the top. Its corresponding Y value is 500 right here. So I'm going to put in 500 as my Y value right there. That's the ordered pair 1, 500 in the slope formula. But then we have the X value that's 5, so that's got to go on the bottom. And then the 312,500 is going to go on the top. When I put this into the calculator, this will give me the value of mosquitoes. Looks like they're increasing, by the way. So when I put this into the calculator as usual, I'm going to put these numerators and denominators in parentheses. So let's type this in. Let's see what we get. So I got open parentheses, 500 minus 312,500. I think I typed that in right. Divided by, because that's the fraction line, open parentheses, 1 minus 5, close parentheses. Enter. And my calculator says that we get 78,000. Now there's context to this, right? Because there's labels. Again, there's not context to the labels, but we do have the labels. And so for this one, again, it's always y's per x. So the y's, this is mosquitoes. So I'm going to label this in mosquitoes. And yeah, I couldn't spell mosquitoes without help there. Mosquitoes per, the x is labeled in weeks. Mosquitoes per. Now the per is always per 1 week. This is a unit rate for us. So hopefully that makes sense to some of you guys at least. But either way, again, you may have to type those in. You may have to just choose them from the drop-down menu. Just be aware of that on the assignment. 78,000 mosquitoes per week. And now this is positive, so whatever this context is, they're approximately adding 78,000 mosquitoes per week. We do have exact values for the x, for both x's. So there isn't going to be any, on the assignment, it won't let you be off at even a little bit on this because we do have exact values to work with. And again, the formula is the same all the time. It's always the y values on the top, x values on the bottom, always subtraction as well. So just be aware of that. On these ones, since we did not need to approximate, we can get an exact value on this. A Petri dish starts out with 15 bacteria. The number of bacteria doubles every 12 minutes. Use the table below to calculate the rate of change for the interval 0-36. So you got these boxes. The first box is for the number. These two boxes are for your labels, okay? And remember, it's always y's per x. So you'll have to type these in. Even on the assignment, use the table. Use the table for these values. So since we are using a table for this one, you should have exact values on this one. No estimation. But take a minute, try this one out, then we'll go over it. Okay, so it gave us x and y values from the interval here. And since we're looking for a rate of change, that's, again, just another way to say slope. So I'm going to use the slope formula on this one. It's always a fraction line with some subtraction on both the top and bottom, numerator and denominator. And I know that x is going on the bottom, y is going on top. So the first x value that they give us, x1, is 0. So I got to find this in the table, right? So there's x is 0. Its corresponding y value is 15. So this is an ordered pair of 0, 15. So I can put this in the table. The x is 0, so I put it in the bottom. The y value is 15, y values go on top. So there's my ordered pair 0, 15. Then they also say the second x value from the interval is x2. That is not an ordered pair. So 36 is my second x value. I found it in the table right there. And its corresponding y value is 120. So again, this is an ordered pair. And the x value is 36. X values go on bottom, so I put the 36 on the bottom. And then its corresponding y value is 120. Y values go on top. So this is the two ordered pairs that we had. When I put this in the calculator, I got to use parentheses around the numerator and denominator. Again, that's just for the calculator. When I do that, I got 2.91, and then there's just a bunch of sixes after that, and then maybe 7. So that just tells us that the 6, it just repeats. So I'm going to round this. I'll round it to the nearest hundredth like we did the last one. Since I'm looking at the hundredths, which is a 1, place value to the right is 5 or more, so I'm going to add 1 to that hundredths place value. So 1 plus 1, that would make 2. So again, this is now an approximation because we did round. But again, these values are they're constant. So you can't change these values. You have to use these values because they were given in the table. So in the boxes, I can now put 2.92 in the first box. The second box is the label of the y-axis, or the y values, which in this case is bacteria. You wouldn't want to type number of bacteria. 2.92 number of bacteria just sounds weird. So I'm going to type in, I would type in bacteria here. I don't know if that's plural for bacteria. I also don't care. But that's the Y values label, and that would be for the X's per X's, which is in minutes. Now that's a unit rate though, so I'm gonna just put an individual minute, not plural on this. So it's 2.92 bacteria per minute. Again, on the assignment, you're gonna have to actually type those in. And if you do not type them in correctly, it's not gonna give you credit for those. So just be aware of that. You need to pay attention to your typing and your spelling. And yeah, if I spelt these wrong, then it would mark me wrong as well. So just pay attention. They gave us these labels in the table. Just look at the table for these labels. There's the objective again. I can find an average rate of change for a specific interval. We now know that we don't care if these are linear or exponential. The average rate of change is just using the slope formula for the two specific values that are given in the interval. An interval is not an ordered pair.